In section 6.4, we give a combinatorial interpretation of the basic inequalities. Recall that in the two-dimensional strongly joint typicality array, there are approximately 2 to the power n times entropy of x rows, approximately 2 to the power n times entropy of y columns, and approximately 2 to the power n times the joint entropy of x and y number of dots. Evidently, the number of dots must be less than or equal to the number of cells, and so we have 2 to the power n times the joint entropy of x and y less than or equal to 2 to the power n times entropy of x, that is the number of rows, times 2 to the power n times the entropy of y, the number of columns. Taking the logarithm and dividing by n, we have the joint entropy of x and y less than or equal to the entropy of x plus the entropy of y, or the mutual information between x and y is greater than or equal to 0. Let us now give an interpretation of the non-negativity of the conditional mutual information Ixy given z. First, we fix a sequence z in S sub z. By the consistency of strong typicality, if the triplet xyz is jointly delta typical, then so is the pair xz and the pair yz. Now the triplet xyz being jointly typical is equivalent to the pair xy in the conditional typical set txy given z of that particular z sequence. And xz jointly typical with respect to pxz is equivalent to x in the conditional typical set tx given z of that particular z sequence. Similarly, the pair yz being delta typical is equivalent to the sequence y in the conditional typical set ty given z of that z sequence. Therefore, if the pair xy is in the conditional typical set txy given z of a particular z sequence, then x is in the conditional typical set tx given z of that z sequence, and y is in the conditional typical set ty given z of that z sequence. Therefore, the size of the conditional typical set txy given z is less than or equal to the size of the conditional typical set tx given z times the size of the conditional typical set ty given z. By the conditional strong AEP, we obtain 2 to the power n times entropy of xy given z less than or equal to 2 to the power n times entropy of x given z times 2 to the power n times entropy of y given z. Or equivalently, entropy of xy given z is less than or equal to entropy of x given z plus entropy of y given z, which is equivalent to Ixy given z is greater than or equal to 0. In summary, the quasi-uniform array provides a combinatorial interpretation of information inequalities, and it is related to many branches of information sciences, including combinatorics, group theory, which is discussed in Chapter 16 of this textbook, Kolmogorov complexity, network coding, which is discussed in the second part of this textbook, probability theory, matrix theory, quantum mechanics, etc. To probe further, you can take a look at a tutorial entitled Facets of Entropy by myself, which is available in the form of a tutorial paper, a set of slides, and a video.